Well, let's go ahead and get started. Um, so as you've probably guessed by now, also probably based on the label on my Zoom screen, uh, I'm Andrew Miles. I'll be your instructor. Over the next couple of days, I can tell you I am legitimately excited to be here. I really, really enjoy teaching this class. It's a tremendous amount of fun for me. Hopefully it will be fun for you as well. And yeah, so over the next maybe 5-10 minutes, you're going to see 50-60% of the PowerPoint slides in the entire course, just because I need to give you some introductory information. And then the most of the time is just going to be getting stuff done in R. So what are we trying to accomplish here in this course? So the goal is really to focus on fundamentals. Um, if you're here, I expect that you already know how to do, the basics of data manipulation. You know how to run analyses. You've just perhaps not been doing that in R. So we're going to take knowledge that you already have and see if we can transfer it over to R. But because you come from many different fields, um, many different parts of the North American continent and beyond and so forth, we can't possibly cover all of the applications that you will use R for. So I'm going to really try and spend some time focusing on things that cross-cut various sorts of disciplines, things like, what counts as good coding in R and often in other languages as well. How do you get help? And then fundamentally just sort of getting inside how R thinks. How does it approach data analysis so that by the end of the course, you're well equipped, right, to branch into whatever direction that you need to go in. And then core concepts, we're going to repeat them again and again and again, right? So first time or two, you'll be like, I got to go look at my notes. Hopefully by the end of the course, the most fundamental aspects of what we do in R will be coming pretty easily to you. Now, I have a couple of recommendations about how to learn an awful lot during the course. Okay, so this course is designed as an active course, right? Like you are, if you wish, I cannot stop you from sitting and just watching what I do on the screen, but I've designed the course around the idea that you would be coding along with me. The pace that I go at, the way that I approach things is that we will all spend a lot of time with our fingers on the keyboard. And there'll be very little of me just talking. So please code with me. If you just wanted the information, those course notes that are in the Google Drive, it's like a big 140-page document that actually has all of the code that we'll use unless we go off on some sort of crazy tangent, right? But that has everything, right? And so I recommend actually that you use that as reference material, particularly if you sort of get caught up on something and you just need to catch up. You can sort of copy and paste. But again, it's reference material. I really don't expect you to use that a lot during the course. We're going to do a lot of things together. Oh, yeah, forgot that was my next point. Use that as reference material. It also has lots of bonus information. I've taught this course many, many times. And there were just things that, due to time considerations and other things, I just couldn't keep in the live presentation of the course. But I mean, I suspect many of you have written articles and other sorts of publications. It's really hard to take things that you have carefully crafted and just get rid of them. So I decided I wouldn't do it. And I just left them in the notes as additional material that you're welcome to go back and learn from. Okay, so one of the first things that I want to introduce you to is a conceptual distinction. So as most of you are probably already aware, R is open source, right? R is user-driven in a lot of different ways, and that is both a blessing and a curse in many respects. It means that some of the most cutting-edge stuff that you find in all of kind of statistical analysis is found first in R because it's a very flexible language, and so a lot of the people who develop those methods are writing packages in R, so it shows up there first. The downside is there is no paid professional team to help you resolve errors, right? Now, there's a huge user base, and typically you can find what you're looking for by posting to forums or looking at what's gone before. So again, I haven't found that to be a huge issue, but I've also I freely admit, having used other programs and still using other programs sometimes, it's nice to be able to send an email to Stata Help and they're just like, have you done this, right? But that is less available in R. Now, one of these things that has happened sort of, I'd say in the last 10 years or so, is there's been kind of this division between what we might call base R and the tidyverse. Now, base R is R as it has always been, so to speak, right? They're the core set of commands. In R, we call them functions, that have kind of come installed with R, and many other R packages, which again, packages are the way that you extend R and R's functionality. Many of those packages are written using these base R functions. Now, that's all in R. It works really well. Last 10 years or so, there have been some folks who have introduced this thing that they call the tidyverse. What the tidyverse is just a collection of packages that share a particular philosophy of how to approach coding and data analysis, right? So this is from the web page for the tidyverse. You'll see down here that it says it's an opinionated collection of R packages designed for data science, right? Now, for our purposes here, this distinction is important largely because you will see both out there. When you're looking for code, when you're looking at different packages, some packages are written in a way that really references base R. Some of them are kind of lean heavily into this tidyverse philosophy. And so at a minimum, regardless of what you end up doing, you need to be able to recognize and understand the code from both. Also, I think sometimes there are easier ways to do it in one approach or the other. So what we're going to do in this course is I'm going to introduce both. You can assume that the things that we're talking about come from base R, unless I tell you that they're from the tidyverse. But sometimes the tidyverse has some really great approaches to doing, data analysis. They make certain things easier to do. So I wanted to incorporate that functionality as well. But again, the goal is, how do we accomplish basic data analysis and data coding sorts of tasks with minimal hassle, while also introducing you to enough stuff that you can not be lost when you go out there and search the internet for all of the many places where people are using R. So again, this is just sort of a conceptual distinction for now, but we'll see more as we move forward. Okay, I believe at this point, we can start talking about R. So go ahead to your course folder, and I'll share my screen here so you can see me doing this along with you. Let's see, desktop one. All right, let's get these PowerPoint slides out of the way. Yeah, so here's a copy of the course notes, right? I have up here, it's a big old monstrosity of a document. If you're following along in the course notes, we're at this section here, the basic structure of R. All right, so what we're going to do here is we're going to open up RStudio, because it's actually a really nice way of demonstrating some basics of R. So if we come in here, I've downloaded our course folder here to the desktop just for easy access. And inside, there's just a whole bunch of different stuff, right? A bunch of files that we'll use during the course. There's some data code books. There's some extra stuff. What I would like you to find right now is this file called irda.rproj. irda.rproj, it's something called an R project file. It is a invention of the people who made RStudio. And it's just, for our purposes, it's kind of a nice, easy way to open up a nice, fresh session of RStudio. If you've already opened RStudio otherwise, that's fine. I mean, it will work just the same. But if you haven't, I recommend coming through this R project file. So I'll go ahead and double click that. And RStudio will pop up here. Now, R is something that's known as an object-oriented language. What that means is that everything that you do in R, you do by finding these sort of conceptual things they call objects and doing stuff to them. In fact, everything that we use in R, the data structures, the commands or the functions that we use, all of them are stored in objects, which you can think of as sort of just, again, just little units of computer memory or something. So there are two main places that R will find objects. The first is what's called your global environment. Think of it as like your user workspace. In RStudio, you'll notice up here there's this big panel, I think is what they call them. A big panel here. Up at the top, it says global environment. Tells me that I'm looking at my global environment, and right now we haven't done anything, so my environment is empty. You'll see as we move forward that we'll start importing data, and doing other things. We'll be fitting, regression models. Not today, unfortunately, but down the road. And then this environment will fill up with various types of objects. The second place that R finds objects is in packages. Now, again, packages are just collections of R objects. Typically, they're functions, commands, and that allow you to do different things, right? But it doesn't have to be, right? A package can come with data or with other types of R objects. If you come up here to this little tab at the top where it says global environment and click on it, you'll see that there are a number of packages that just load up automatically when you open R. These are sort of collectively that base R that I was talking about. And if you click into any one of them, let's click into stats, you'll see that there are they call them values. It's not a very helpful name, right? But there are all of these different things, which are essentially functions, right? They allow you to do different types of things, right? So we have Q chi-square, QT for, the T distribution, RT, R plus for the, a random Poisson distribution. But again, all kinds of different things. But these are all objects. R sees these as objects, even though what those objects do might differ. But again, that's just sort of a high-level overview. Everything in R runs through these objects. We find them because we've brought them in ourselves and created them. That's most often the sort of objects that you'll be kind of thinking about, but also in packages, right? All of these functions that we use are actually objects as well. Okay, let's talk about this RStudio interface here for a second, because this is kind of nice. So RStudio is not R. R is the actual underlying program that will run your analyses. We almost always use it through an interface. You don't have to, right? Really hardcore R users can actually, open up the I forget what it's called on a Windows machine, but on Mac it's like the terminal. It's like command line interface. And you can run R, right? Like that. But again, most of us don't do that. R has a basic graphical user interface that it comes with on a Macintosh. It looks like this. This is what I used for many, many years. And sometimes when I just need something simpler, I will still go to this user interface because it brings me, a feeling of joy. But RStudio really is quite handy. It's something that lays on top and takes a lot of the stuff that's hidden about R and stuff that's useful for you, right? As somebody who's using R, and it just brings it forward so that you can see it. So you'll notice that we have, in this case, 3 different quadrants. RStudio is actually designed to have 4 quadrants, but the 4th one contains something that we haven't started yet. So let's, or we haven't asked for yet, which is a code file. In R, we call these scripts. It's like in Stata, you call them do files, right? But in R, it's a script. So let's go ahead and open one of those. We're going to be using that quite a lot as we move forward. If you come up here to the RStudio menu under File, New File, you'll see that there are actually lots and lots of different types of files that you can create using RStudio. RStudio is really trying to move to be a more a nice interface for lots of different programming languages. Really pushing hard on Python right now, for instance. But we're just going to use the R stuff, right? So this R script is what we want. So File, New File, R script, and you'll see that it pops up down here. So now we have 4 quadrants, right? And you can use your little handles here to make them as big or as small as you want. Or I always forget to mention this, and somebody always asks me about it, so I'm just going to show you right now. These little tabs over at the side will minimize or maximize the tabs. So like if you don't need to be looking up here at your environment, you can just click this and then have more space for your code. So you'll almost certainly will see me do that at some point. So that's what I'm doing. And then when it's maximized, you can click this 2-window thing to move it back down to 2 windows. So again, different things will show up here. I'm not going to introduce most of them right now. The ones that we use, you'll see as we move along. And then you can explore the other ones at your leisure. The two main ones where we'll spend a lot of time, at least right now, are this script file. This is where we're going to write all of our code. And then all of the results show up over here in the console. You can also enter commands directly at the console. The disadvantage is they're not saved, right? So we really want to work in the code file so that we have a record of everything that we've done. Now, some of you might be wondering, hey, Andrew, mine looks a little different than yours, right? So if you would like to set up your arrangement of these these 4 panes in the same way that I have it, I'll quickly show you how to do that. If you don't care, if you can follow along, no problem, then you can ignore the next, minute of what I say. But if you come up here to the Tools menu, come down to Global Options, these will change basic things about how RStudio operates. So Tools menu, Global Options. And then there are lots and lots of different sorts of global options. Come down here to Pane Layout. And you'll see that it has like 4 little boxes. And then they're kind of like the certain types of panes, and you can just arrange them any way that you want. So if you want to mirror what I'm doing, in the upper left corner, you'll have the Files, Plots, Packages, Help, Viewer, Presentations pane. Below that, you'll have Console. Top right corner will be Environment, History, Connections, blah, 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 blah. And the bottom right will be Source. Again, I think RStudio by default switches the source and the console. For whatever reason, I find that aesthetically displeasing. Maybe I just like to work on the right side of my screen. So that's not what I do. So if you want to match me, this is where you do it. If you don't care, then it doesn't matter. Come down here when you finish and click Apply. One more thing I should probably mention, because this almost always happens to someone. If you come up here along the side to, not console, to Code, click on Code, and again, there's lots of different things that allow you to change how your code works. One of them that a lot of people want is this soft wrap R source files. If that's not selected, I recommend that you select it. It just means that when you start writing your code, when it hits the edge of the screen, it won't keep going. It'll wrap around, so it all stays visible. Again, there's always 1 or 2 people, for whatever reason, that's not selected, so I recommend selecting that. Yes, question.
Yes, sorry. So in order to change the layout, is it not a drag, or sorry, how did I might have missed that.
It's just a drop down menu here, right?
Oh, gotcha.
Yeah.
Got
So
it.
you just click on it, and then you drag and drop would be cool, but it's not that fancy, right?
Got it. Thank you.
Yeah, no problem. Any other questions about kind of this nuts and bolts stuff? Okay. So I believe, yeah, let's start. See what time it is. I've sworn with an oath to myself that I'll give you a break about every hour. We'll take about 10 minutes because Zoom's kind of that way. Yeah, so we'll have one break. We go a couple more minutes and then we'll take a break. And then we'll dive on, and we'll have a nice big break in the middle. Which we didn't used to do. So you're very lucky. We used to do like 4 hours straight and just hardcore, and people were like, oh no, don't do that. So we stopped. All right. So let's go ahead and talk about our first topic here. So we'll say importing data. Now, you'll notice that I use this little hashtag over here to write a comment. That's how you write comments in R. It will comment out 1 line, but again, if you have that source wrap on, you can make the line as long as you want. And again, after you've done 1 hashtag, you can do as many as you want, right? You can actually type some stuff, and then put a comment at the end of the line, right? It's just really as soon as that hashtag starts, you'll have a comment. So do whatever makes your notes look beautiful to you. But yeah, let's import some data and use it to talk about some fun R-related stuff. Now, strange to say, often importing data is one of the hardest things that people struggle with, not just in R, but generally speaking, because it requires you to know how to find things on your computer. So for instance, if you know what a file path is, then you are actually ahead of many people who have always used, point and click menus. And so what I'm actually going to show you is a way of sort of avoiding the file path, but know that R accepts file paths. And if you don't know what I'm talking about right now, don't worry about it for now. So the first thing that we're going to do to make our lives as simple as possible is we're going to point R to the folder where all of our course material is. It's something called setting the working directory. And again, the working directory is just the default directory that R will look at anytime we ask it to read a file, write a file, do anything like that. So here's how we set our working directory. We'll start with the easy way, and then anyway, we'll start with the easy way. So you can actually do this via the menus in RStudio. If you come up here to the menu that says Session, you'll see that there's an entry that says Set Working Directory. So again, that's Session, Set Working Directory. And what we want to do is come down here to Choose Directory. So Session, Set Working Directory, Choose Directory. And what that's going to do is it'll just pop up a window on your computer, again, whatever that looks like on your operating system. And what you want to do is go in and find, wherever it is located on your computer, our course folder. So for me, that's on the desktop. So I navigate using these windows to the desktop. I click on the ERDA folder. And then once you've selected it, just click Open. Okay. So again, just in case you missed that, we go Session, Set Working Directory, Choose Directory, and then find our course folder. Now, once you do that, you'll notice that R will print out some code down here in the console. That code is actually what's doing the work. So what I recommend that you do is you copy this code and put it in your code file. So over here, I'm going to write a comment. So set the working directory. And I've just pasted in this code that RStudio automatically generated for me. Now, what that means is the next time we set our working directory, we won't need to go through the menus. We can just run this line of code. Now, your line of code probably looks a little different from mine because your computer is configured differently. This is, for all intents and purposes, the address of that folder on my computer. Your address will look differently because your computer has different folder names. It's configured differently. And this is also the file path, right? So this is going to be taken as kind of our default file path anytime we ask R to work with a file. Now, setting the working directory, this is something that in R will last generally for an entire session. So as long as you keep RStudio open and you don't change the working directory, it will stay pointed to this folder. When you start R over, if you shut down RStudio and open it back up, you'll need to reset your working directory. So typically, again, the advantage here is you can have different code files that point to different folders for different projects, and you just include it right there in your script file. So that you never rely on R's defaults to give you what you want, right? It's always in your code file, which then makes it very transparent for other people to see, and frankly for you to see later on down the line when you're like, where is that file again? Right? It's all right there. Questions about setting the working directory? So we've set our working directory. What we're going to do now is do something called loading the Rio package. Because So again, R has some basic functionality for reading in different sorts of data. If you want to read in lots of different types of data from lots of different, typically proprietary software, SAS data, etc., you need add-on packages. And as of a few years ago, by far, the best one that I found is the RIO package, stands for R import output, I think, or input output. So we're going to load that package into memory and use it to import some data. So in R, the way that you load a package is using this command called library. And then you type the name of the package in parentheses. So again, R, anytime you see a word followed by these parentheses, that's a good indication that you are using one of R's commands or accessing one of its functions, and you're trying to do something. So here we're going to try and load this this package called Rio, and the command library, if it's helpful, you can think of it as, once you've installed a package on your computer, it's sitting there in the library, and if you want to use it during your R session, you have to go check it out from the library and use it. Now, R by default is very minimalist. Every time it starts up with a nice clean session, which means when you load a package, it will only persist for your session. It disappears as soon as you shut down R. Now, depending on your background, that might be familiar or very unfamiliar to you. I think an advantage of that approach over something like, say, Stata. Again, I'll make references to Stata because that's the other major package that I've used. Is Stata, you install something and then it's just installed, right? You don't have to worry about loading it into the session, which is really convenient for you as an analyst. But you do run into problems if you then write code files that you try and share with other people, and they don't know that you've used an extension or an add-on, and you have to go in and find it right in your package. And you might even forget, right? That this is an add-on and extension rather than something that comes, prepackaged with Stata. So the advantage here is that it's always in your code file. It's very clear which packages and extensions your code will rely on. So I think it's actually a feature rather than a flaw. All right, so let's go ahead and run this line of code. Now, if you want to run a line of code, you can select it or just put your cursor in it. And you're welcome to come up here and hit this button that says run. If you dangle your cursor over that for a minute, a little tooltip will pop up and you'll see that it gives you a keyboard shortcut. I recommend you just learn that keyboard shortcut, whatever it is for your system, because it will just make it easier to run code as we move along. And you will see that I never use this button, right? It'll look like I just click on a line of code and it runs, and it's just because I'm using this keyboard shortcut. So I'll click here. I'll use my keyboard shortcut. And we see down over here that the code appears. And then underneath, it pops up this message. Now, this message is not an error, even though it's written in red. That is I think, a unfortunate design decision by those who have decided to, make that font red. That's actually just a message. The person who wrote Rio said, hey, if you've installed this package, but you haven't installed some of these extra packages that would extend the functionality of the package, I should let people know about that so that they know they could install these additional packages, which would then make Rio be able to essentially work with more different types of data. Now, we're not going to work with any of those types of data, so we're not going to worry about that. But yeah, I just wanted you not to be thrown off by the fact that it printed something out. Most of the time when you load a package, it won't print anything at all. Sometimes it will. Different packages have different levels of chattiness, if you will. Okay, so we've loaded the package. I want to show you a couple of different things here, just again to tie together how R works. So I'm going to come back up here. Do you remember when I said packages contain different sorts of objects, et cetera, et cetera, et cetera? If we come back up here into our, which tab is this? So I have some Zoom stuff locking it. Our environment tab, yeah. If we click on this up at the top, you'll notice that the package Rio now appears in the list, right? So we've loaded another package. So R has access to all of the objects inside this Rio package, most of which are various sorts of functions. Yeah, question.
Sorry, I think there were a couple of us that had some errors that we put in the chat. Mine very quickly was it was not finding my it wasn't liking my path file.
Okay.
Not
Yeah.
so mine
So
says error unexpected caret in caret.
yeah. So there are a couple of things if you're getting an error here. Step one, double check your code, right? So if, for instance, your code over here had a caret in it, then like
Oh,
that
I
is
gotcha.
right. It doesn't like that. The caret is really just the prompt. It just shows you where the prompt is. If it says there is no package called Rio, that means you haven't installed it yet. And the way to take care of that would be to do install.packages and then Rio like this. So if the package is not yet installed, do this. Now, again, you don't have to install the package every time you use R. Once it's installed on your system, it should work. There was another error message in there that said something about, Rio was built under a different version of R. What you're running into there is, so when R software updates, then packages usually have to update to stay current with R so that they keep working properly. And typically that's just a versioning thing, right? So as long as you have the most recent version of R, and then you've downloaded a more recent version of Rio, then you should be fine. What might happen instead, if you've installed R before, is you might have an older version of R, and then you try and install a version of the package which was built under a newer version of R, and the solution there is to update your R, right? I mean, you could go find an old version of the package, but that actually ends up being more work, in my opinion. So I'll say this for now. As long as you understand the concept of what we're about to do, we can work around the fact that you need to update your version of R, so you don't have to do it right now. For the next little bit, right? And we can, if you need, we can stick around during the long break in between sort of the morning and the afternoon session. And anybody who needs to, I can help you work through some of these installation issues. Okay, I think that about covered the major error messages. Okay, no one is crying out in panic, so we'll move on from here. Okay, so to load the Rio package, yep, let's actually import the data now. Oh, sorry, that was the other thing I was going to show you. I wanted to show you that the Rio package shows up here. But I also wanted to show you over here on the files, plots, packages, etc. tab. You can click on the packages tab and there will be a list of all of the packages that are installed on your computer. That's a quick way of checking whether a package has been installed or not. And if you really hate coding and writing stuff in your script file, first of all, this will be a painful 4 days if that's the case. But one of the things that you can do here, if you scroll down here to the Rio package, since that's what we're working with, you'll notice that the Rio package has a little checkbox next to it. That's just RStudio's way of telling you that it's been loaded. You could uncheck that and it would print out the code which would unload the package. You could check the checkbox and then it will print out, right, the code that will load it. So that, again, if you ever forget how to load a package, you can do it there and then see the code that pops up. Okay, so let's go ahead and import the data. I'll move that up there so it's a little easier to see. So what I'm going to do now is I'm just going to type out some code and then I'll go back and explain what all of the pieces are doing. All right. So the function that's actually reading the data in is this function called import. And again, that's located in the Rio package. Inside the parentheses in R, you just give all of the information that you need to get a function to do what you want it to do. So we supply a file, And the name of that file, again, in quotation marks, you can use singular, double quotes, it doesn't matter, is binary.csv. Now, this is actually in our course folder. If you go take a look in our course folder, we have a file called binary.csv. And because we set our working directory and R is pointed towards that folder, we can just write the name of the file and it will load it in. If we had not set our working directory, then we would have needed to include the entire file path, essentially this bit with all of this pasted onto the front. Again, as long as R can find the file, it can read it in. If you run into an error ever where it says there is, we couldn't complete this data import, right? There's no such file or directory. It almost always means it just couldn't find the file on your computer. You didn't type it right, something like that. All right. So this collectively is going to take the data from that file, read it into R, and convert it to a nice data format that R understands. This over here is going to take that information and assign it to an object. So it's going to create an object called D and set it equal to whatever this command does. This equal sign is something called an assignment operator. You'll sometimes hear that term. There are actually two assignment operators in R. I'll show you the other one in a minute. But this will read it in and put the information in an object called D. Why D? Because D is the first letter of data. And I mean, you name it whatever you want, right? It will be in R, whatever you name it. If you want to follow along with me, I recommend D. And for reasons you'll see as we move forward, I like nice, short names of data objects. All right, so I'm going to go ahead and run this line of code. And again, over here, you see, let me move this up. So if you didn't see what I just did, if your console is getting a little crowded there, you can click on this little broom here or use the keyboard shortcut and it'll just kind of clear out your console. I'll do that occasionally just so that it's easier for you to see. So I've imported the data. If we come back here to our environment tab, notice that in our global environment, we now have an object. It's called D. RStudio recognizes this as data with 400 observations and 4 variables. We could even click on this little arrow doohickey over here, and we see the names of the variables as well as some basic information about them. But again, for our purposes right now, I just want to point out we imported it. It shows up as an object in R with the name that we gave it, which is D. Now, I'm going to take this command and alter it slightly. And the note I'm writing in here says, this does exactly the same thing. So if I do this, again, this is exactly the same with one difference. Instead of that equal sign, down here I have what looks like a left-facing arrow. This is another assignment operator in R. It does exactly the same thing as the equal sign. Some people like it because it sort of visually looks like you're taking the output of this command over here and shoving it into an object called D. And in fact, when you look up R code online, most of it uses this leftward facing arrow. But I do not like it. I think I don't know, I think it looks ugly. I really like the equal sign, so that's what I'm going to use. But you will see this left-facing arrow out there, and it's doing exactly the same thing. So if you have a preference, use whichever one brings you the most joy. I'll be using the equal sign. Leanne, yes.
How flexible is this import command with different file types?
I'm so glad that you asked that question. One of the reasons I like Rio is, so what Rio actually is it's sitting on top of a bunch of other packages that have been written to read in lots of different file types. And so it will read in many, many different file types, including from all of your major, statistical software companies, right? It'll read in SAS data, SPSS, and so on, right? And once I show you how to use help files in R, you can look up the help file and you'll see it like list out all of the different formats that it uses. CSV files, tab limited. And I like it because it will automatically recognize if I were to come in here and change this from binary.csv to binary dot SAV, which I think is SPSS's format. As long as there actually is a file called binary.save that's saved in SPSS format, it will find it, it will pull up the appropriate internal function, it will read it in, and then again, the really nice thing about this, the reason I really like it, is it always produces the output in a consistent format. So you always know what you're getting. So regardless of this other stuff, the nuances and the things that make a SAS data set a little bit different than an SPSS data set, it kind of strips those things away and puts it in a format that works really well for R. So yeah, I'll move this back in case you're copying my code, so you don't try and read that in. And again, all you have to do is just put the name of the file. It will do all the work for you. So it might have been you, Leanne, or someone else who asked, what about a SAS file, right? Just type the name of the file. Same command works for everything. This is why I like Rio, right? It works very well. Okay.
There's a question in the chat.
Oh yeah, again, like I don't always look directly at the chat. So if there's a question that's urgent that you need to answer, just raise your little, I guess it's a little on my screen, little digital hand. So yeah, Rachel, go ahead.
Yeah, I'm just getting an error message that it's not finding, sorry, I've generated a lot of error messages now, but an unexpected symbol.
Okay. Have you taken your error message and pasted it into the chat?
I'm not letting, I can't do a cut and paste either from the console.
Yeah. So, are you working Windows or Mac?
Windows.
Windows. I think in Windows, right, you can right click and allow you to just copy the text. If it's not, we can troubleshoot during the next break. What we're doing right now, as long as you understand the concept of what we're doing, we can troubleshoot the details later. So again, I'm showing you how to import the data, and then the data that we're going to work on moving forward, we're actually use a different import command that doesn't involve external packages because it's working with R's native file format. So there's a little flexibility there.
Okay.
So if you're not able, again, if you're able to paste it into the chat, then other people in the class can be sort of looking at it, and it might get resolved. If it doesn't, as soon as we have our next break, I'll be right there in the chat looking through, making sure that everything is working. Any other questions? Yeah.
Where do you click to show the data observation, 400 observation?
So you like to actually see the data?
No, just you have a window. It says data and then show 400 observation.
Oh, right.
I don't see the window. Thank you.
So yeah, this is in one of our 4 panes. This is our the one where we are looking at the global environment. So as long as you're clicked in here to global environment rather than, so I moved us earlier down into like package stats, which shows all of that. You just need to move back to global environment and it will show you all of the objects that are essentially in our user workspace, which right now is just this one data set.
Okay, got it. Thank you.
Yeah, no problem. All right, I want to show you one more thing about these packages, and then we're actually going to read in a different data set. Oh, no, I'm going to show you about R's import command, which is, anyway, it's very cool. So what I'm going to do now is I'm going to type exactly the same line of code. In fact, I'm just going to copy and paste it. I'm going to add one little bit here, which is this. So again, the bit that I've added is this highlighted part down here. This is something called a package prefix. Now, what a package prefix does is it will tell R where one of your functions is located, even if you haven't loaded it into memory like this. So because we loaded the Rio package in, you'll notice this import command worked absolutely fine, right? We don't have to reference the Rio package. But occasionally you might want to use a function from a package without loading it into memory, in which case you can use this package prefix. It also makes your code, again, it's a little longer, but it's also extremely clear. I know not just that we're using the Rio package in this code file, I know that this function comes from the Rio package. Now, again, technically, we don't need this because we've already loaded the Rio package. But as we move forward, you'll see that occasionally I will use this package prefix because I don't want to load the entire package into memory. And that's just what it's doing. Now, one question that nobody has asked yet, but often people do, is, hey, Andrew, you ran these codes multiple times. Why don't we have multiple data sets in R? Now, this is something, again, depending on your background, that you might consider a feature or a flaw of R. I consider it a feature. And here's what R does. If you execute a command that tries to create an object that has the same name as an object that is already created, it will overwrite the object that is already in memory, and it won't warn you, right? So I can run this line again and again and again, and R has no problem with it. And if I come up here, I still only have one object. Now, again, this is different than, say, for instance, Stata, where if you try and do something like this, it will get angry with you. It will say, it's the most aggressive message I've ever seen in the Stata. It says, no, data in memory will be lost. And that's the way they designed it. I find that annoying, right? Like, R assumes, and I typically, when I'm approaching my data analysis, assume that I know what I'm doing with my code. And if I'm wrong, I can just rerun my code and fix everything. But whether you like that or not, you should be aware that that's what R does, right? So running this, and this will, again, they will all do the same thing, but you'll still, at the end of the day, only end up with one imported data file. Yeah, question.
Could you name various different objects just to importing various different data sets?
Absolutely.
Okay.
And this is, again, this is another thing that that stems from this object-oriented design of R, which is quite a flexible feature of R as compared to some other data or statistical packages. Because data sets are simply objects in R, you can put as many objects in R as you have memory for, which means you can put as many different data sets as you want. You can put different versions of your data set, which you'll see us do at some points. I'll be like, here's my original data. Now we're going to modify it in some way. We'll store it in a slightly, in a different named object, data original, data small, data this, right? And you can have multiple data sets in memory at the same time, work back and forth between them, run some descriptive statistics on this one, do something else on this one. So again, a tremendous amount of flexibility.
So is there a character limits for the objects?
In terms of the names?
Yes.
I have not found one. I once, it's actually interesting you asked that. I tested this not just a couple of weeks ago. I created an object name that was, I think, 2,600 characters long. I wasn't courageous enough to create a longer name, but yeah, you can make it as long as you want. I mean, there are obvious downsides to making really long object names because you have to refer to them later. And there's always a trade-off between the clarity of your code and how much you hate your life having to write the code. So again, I tend to lean in towards very small generic object names. But if I need to for clarity, I'll make it longer. Great questions. Okay, so let us see what's going on here. Again, if you're interested if you're interested in other ways of importing data, there's a section in your notes that I call more ways to import data, has a bunch of other functions that we use, or that you can use. Again, I don't think any of them are quite as easy to use as Rio, so you're probably fine just sticking with the Rio package. Exporting data, also with the Rio package, just as easy. And you do it like this. Oh, in fact, we'll just do it like this. Now the command here is called export. And what you do is you put in the name of your data object, which again, we created a data object called D. We've placed that in right here, and then you just specify the file that you'd like to write it to. Now you'll notice I didn't include any kind of file path here, so this is just going to be put in my working directory. If I wanted to, I could do something like this. Again, if you have a Mac, this is going to put you right on your desktop. But again, this is just the file path, right? The name of the file is back here. And I'm creating a file called d.dta. DTA is the file extension for a Stata data file. So this will automatically take this and convert it into a Stata data format, right? If I had done SAV, it would convert it into an SPSS format. If I had done CSV, comma separated value, whatever the SAS one is, it's like SAS7B dat. Like I can never quite remember that one, which is why I'm nervous to type it. But yeah, it will just do it for you. Another thing I really, really like about this. And then, yeah, so we can export the data. No error messages print out, which means we can now come up here and you'll see, again, this is just my the folder, that course folder. And somewhere in here, we should now have, what did I put? Oh, I put on my desktop. That's why. Here, let me erase this desktop thing here over here. Go back into our working directory, and we see that it showed up right there, right? Which is being recognized as a Stata data file. Now, some of you might ask, Andrew, do I have to name it D just because that's what the object is named? No. Name the file anything you want. Here is data in Stata, right? The name of the file doesn't have to match the name of the object that is created in R. So I'm gonna go and change this back just so it matches the notes that you have. But yeah, questions about exporting? Okay. So you could use those commands quite happily and work in R for a very long time. I do want to introduce R's data format. And this is going to be the saving grace for some of you who are still struggling to get that Rio package working quite the way that you want until we can get that fixed up. And it goes something like this. So R has its native file format, just like other software packages have its native file format, except in my humble opinion, its native file format is just more awesome than the others. This is a place where R really shines as compared to at least some of the competitors that I'm aware of. So let me go ahead and type something out, and then I'll go back and explain the code. All right. So the command is called load. Inside the parentheses, once again, we're putting all of the information that we need in order to get this command to work right. The name of our file is loadexample.rdata. .rdata here is the file format for our data. And then we have this option verbose equals true. Now, I'm going to show you what this does, and then I'll explain why I think this is so powerful. So I run this line of code, and you'll note that it prints out this message. loading objects, example data, vector object, matrix object, my mean function. And if we come up here to our user workspace, you'll see that we now have a lot more objects. We have example data, matrix objects, vector objects, my mean function. So we've loaded in a bunch more R objects. And again, almost everything we use in R is an object. So a couple of things. First, what did we do? We had a single data file that contains various sorts of objects. This is data. This is a single vector, or like one column of data. We have a matrix, and we have a custom function in R. R sees all of these as objects, and our data files are designed to store objects. Now, what that means is that you can take and store in a single R data file as many R objects as you want. And because everything in R is an object, this makes it really easy to, for instance, be working on a project, pull together, 4 different versions of a data set, maybe the multiple imputations on a data set, a couple of custom functions that you had to write to work on your data set. All of that can go into a single file, which you can then load in the next time you start R, and it's all there for you. Or you could take that R data file and you could share it with a collaborator, and they could load it, and everything's there, right? You could have fitted modeled. Again, everything in R goes into an object, and this just generically stores objects. There's also no limit to the number, again, of objects that you put in here. I know some other packages, they're like, you can save 1 data set per file, or 1 fitted model object per file. None of those limits apply here. This is why I really like R's native file format, and why I think it's worth the time teaching you this. Now, you might have noticed that there is no assignment operator here, right? I told you up here that if you import data, you need to assign it to an object. That rule doesn't apply if and only if you are importing from R's data format. And the reason is it has already stored R objects. So we don't have to assign it to a new object. It just reads in the objects. And if you ask it to, with this verbose equals true, it will print out the names of those objects. So these objects are already named. I can refer to them in R by these names. Okay, let me pause here for a second. Questions about what this is doing, or R's data format? Okay. If we want to save data in R's data format, the command is called save. And again, you just list out as many R objects as you want, right? So we have an object called D, we have one called example data, we have one called my mean underscore function. Again, as many as you want. And then you put it in a file. I'll call it my objects.rdata. And we can go in to our working directory, and we see that we now have myobjects.rdata, which contains all of those different R objects, 2 different data sets and a custom function. So practically speaking, right, if all of the nuances here just kind of went over your head, that's fine. Here's the practical point for us moving forward. Anytime I ask you to read in data, which I'll do, right, in various exercises, the first thing that you need to do is ask yourself, is this R data, right? Does it have the extension .rdata, or is it any other extension? And if it's an R data extension, you use this load command, no assignment operator. It's going to load in an object that already has a name. If it's anything else, then you do it like this. You use the import command from the Rio package, and you need to assign it to an object.